Day 501 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2197, replace the non-coprime numbers in an array. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You're given an array of integers nums. Perform the following steps. Find any two adjacent numbers in nums that are non-coprime. If no such numbers are found, stop the process. Otherwise, delete the two numbers and replace them with their least common multiple, or LCM. Repeat this process as long as you keep finding two adjacent non-coprime numbers. Return the final modified array. It can be shown that replacing adjacent non-coprime numbers in any arbitrary order will lead to the same result. The test cases are generated such that the values in the final array are less than or equal to 10 to the 8th power. Two values x and y are non-coprime if their greatest common denominator x and y are greater than 1, where the greatest common denominator x and y is the greatest common divisor. Sorry, y'all, not greatest common denominator, greatest common divisor of x and y. All right, y'all, so that may seem a little bit confusing at first. Let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into the examples, let's go over what a coprime number actually is. So two integers, or let's go over what a non-coprime number actually is. Two integers are non-coprime when their greatest common divisor is greater than 1. So what that means is, so let's go over an example, right? Let's say 8 and 15 are coprime. These are not non-coprime, these are coprime. 8 and 15 would be coprime because their only common divisor is 1. So let me write it over here for y'all. Divisor is 1, right? So they 8 and 15 are once again coprime because their greatest common divisor is 1. Now let's go over a non-coprime, right? So let's just say this is coprime. Boom. Now let's go over a non-coprime. So an example of a non-coprime might be 8 and 12. Why? Because their greatest common divisor, in this case, is 4, right? So greatest common divisor is equal to 4, right? So we want, once again, it says right here, two values are non-coprime if their greatest common divisor is greater than 1. So once again, 8 and 12, their greatest common divisor is greater than 1. So it's a non-coprime, right? 8 can be divided by 4 and 12 can be divided by 4. Whereas this is a coprime, their only divisor is 1. Their greatest common divisor is 1, right? The only common divisor that these two numbers have is 1, right? And that makes them coprime. Whereas once again, this greatest common divisor is 4, which makes them non-coprime because the greatest common divisor is greater than 1. Boom. So now that we know what a coprime and non-coprime is, let's continue and take a look at these examples. So in example 1, we have our input nums equals an array of integers 6, 4, 3, 2, 7, 6, and 2. The output is 12, 7, and 6. So let's see how they got this output from this input. So it says, so let me copy and paste this over here so we could go through it and y'all can see how it works. Boom. So we start with this. This is our input. Come underneath here, put output array, and then this could just be we'll just leave this blank right here. All right, so it says 6 and 4 are non-coprimes with the least common multiple of 12. So we put 12. So let's see how they got this 12 from this 6 and 4. Well, that's just the least common multiple, right? So The least common multiple of 6 and 4 is 12. You could do 6 times 2 will get you 12, and 4 times 3 will get you 12, and that's the least common multiple, right? So that's how they got 12. So once again, what we're doing is we are finding any two adjacent numbers and nums that are non-coprime, and then we're deleting those two numbers and replacing them with their least common multiplier. So this right here is how we find which numbers are non-coprime. But once we find the numbers that are non-coprime, we're not done yet, because we need to replace those two numbers with their least common multiple. So we going through this array, we see that these two numbers are the non-coprime. These two numbers are adjacent and they're non-coprime. Why? Their greatest divisor is greater than 1. As you can see, we can divide 6 by 2. We can divide 4 by 2. So that makes them, we already know that they're non-coprime because they have a common divisor that's greater than 1. Boom. So now we know that these two numbers are non-coprime. Now we need to find their least common multiple. It tells us right here the least common multiple is 12. Once again, you could do 6 times 2, and then you could do 4 times 3. They'll both get you 12. That's the least common multiple. 24 is a common multiple. However, we want the least common multiple, right? So once we find the least common multiple of these two numbers, we replace them with the least common multiple. So we put 12 right here. Boom. Then we keep going. Now the next non-coprime numbers 12 and 3 are non-coprime with the least common multiple of 12. So boom. So it would look like this. Let's see. Let me copy and paste this. Boom. This is just we call this the work. We call this the work through array. Boom. So hold on. Okay, so we just took these, combined them, now we have 12. So now we have these two, boom, and we put 12 in our output array. So now we have these two, boom. So now once again, these two are non-coprime because they have a greatest common divisor greater than 1, right? Both of these numbers can be divided by 3, right? 12 divided by 3 would be 4. 3 divided by 3 would be 1. So they both are divisible by 3, which means they have a common divisor that's greater than 1. So now we need to find their least common multiple. Well, their least common multiple is 12. We could do 3 times 4, and we could do 12 times 1. So once again, yeah, the LCM, least common multiple, is 12. So now nums is 12, 12. Boom. So, I mean, it would be, I'll show you why it's, these two 12s just end up merging together, and I'll show you why at the end. Boom. So let's just keep it right here. We could just keep, or no, sorry, yeah, because we're merging these two 12s anyways. I mean, these two numbers. So now these two numbers become 12. This 12 can stay the same. Boom. So then we are going to, now we're on to the next one. 12 and 2 are non-coprime numbers with the least common multiple of 12. So let's go through it. Once again, they have a divisor. They both have a common divisor of 2. We know that's greater than 1, so they make a non-coprime. Then we need to find their least common multiple. The least common multiple is 12 because we could do, once again, 12 times 1 will get us 12, and 2 times 6 will get us 12. So the least common multiple, once again, is 12. So once again, we could merge these two and turn them into 12. Boom. So in our output array, we don't really need this because this is gonna end up being our output array anyway. So we could just call it work through / output. Boom. So now we have 12, 7, 6, 2. So now when we have this, we have the 6 and the 2 are non-coprime with LCM of 6. So now we have these two numbers. These are non-coprime. Once again, they're both divisible by 2. They have a common divisor of 2, which is, once again, greater than 1. So now we know the non-coprime. So now we need to find their least common multiple. Their least common multiple is 6. We could do 6 times 1, and we could do 2 times 3. So then we could just merge these into 6. Boom. And then we're done, right? That's our output. It says there are no more adjacent non-coprime numbers in nums. Thus, the final modified array is 12, 7, and 6. Note that there are other ways to obtain the same resulting array. So this is the output. This is the final output, 12, 7, 6. That's how we got it. I hope that made sense to y'all. But just in case it didn't, let's go ahead and take a look at example 2. Example 2, I'm not going to work through it over here because it's simpler. We have multiple occurrences of the same number, and you'll see how those numbers kind of just merge into themselves. So, or I'll show you an example just so you can see how they merge into themselves. So let's just bring this over here again. Boom. This could be the input. Just clean this up. Then this could be, we just call this the work through / output. Boom. We have our blank array. Or we can copy and paste this too. Boom. So once again, so we have our input nums equals an array of integers 2, 2, 1, 1, 3, 3, 3. Our output is 2, 1, 1, 3. So let's see how they got it. It says 3 and 3 are non-coprimes with the LCM of 3s. So we have these 3 and 3. They have they're non-coprime because the greatest divisor is 3. Once again, 3 is greater than 1, so we know that it's a non-coprime. Boom. The least common multiple of these is 3, right? So they have the least common multiple is 3. We could do 3 times 1, and we could do 3 times 1. So the least common multiple would be 3. So we just merge these, and they become 1, 3. And then we will repeat the process for these 3s. We already know they will merge and become 3. Do the same thing for 2. The least common divisor for these is 2. They both can be divided by 2, so that's greater than 1. So we know it's a non-coprime. Boom. Then the greatest common divisor of these is 2. So we know that they're non-coprime. And then the least common multiple of these will be 2. It'll be 2 times 1, 2 times 1. Boom. So then we could merge these. These end up being 2. Boom. Now with these, we leave these ones the same. Why? Because the greatest common divisor is 1. It's not greater than 1. It'd be 1 times 1. They both have a greatest common divisor of 1, nothing more, nothing less. That's why we don't touch these, because these two are coprimes. And then that's how we get this final modified array is 2, 1, 1, 3. Note that there are other ways to obtain this resultant array. So this is the final output, and that's how we got it. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we are going to do is we're just going to create our result array. As you can see, the output is an array, so we need to create that array, and we'll just call it result. So we'll declare a variable called result, set that equal to an array of integers, and put the parentheses like that. Then we need to iterate through each number in the input. So we're going to say for num in nums. Boom. Then we need to push the current number into the stack. So we're going to say result dot append, open up the parentheses, and we're going to pass in num. Then we're going to check if the last two numbers in result share a common factor that is greater than 1. So to do that, well, actually, first thing, we need to come outside this function. We need to create a helper function. So we're going to come right here, and this is going to be a helper function to compute the greatest common divisor for us using the Euclidean algorithm. So we're going to say private func GCD, open up the parentheses, underscore a colon int, comma, underscore b colon int. Then it will come outside the parentheses. We're going to return an integer, and we're going to open up the brackets. We're going to say declare a variable called x, and we're going to set that equal to a, and we're going to declare a variable called y, and we're going to set that equal to b. Boom. Then we're going to say while y does not equal 0, we're going to open up the brackets. We're going to say let tmp equal y. Then we're going to say y equal x mod y, and then we're going to say x equals tmp. Boom, and then we could just return x when y becomes 0, because x is going to hold our greatest common divisor. So we could just say return x. Boom. Now we come back up here to the main function, and we are going to first we need to get the last inserted number. So we come underneath this, or first we need to check if the last two numbers in the result array share a common factor that's greater than 1 by coming right here, and we're going to say while result dot count is greater than 1. We're going to open up the brackets. We're going to get the last inserted number by saying let a equal result square bracket result dot count minus 1. Boom. Then we're going to get the second to last number by saying let b equal result square bracket result dot count minus 2. Then we need to get the GCD, or greatest common divisor, of these two numbers by coming right here and using this helper function we just created and saying let g equal GCD, open up the parentheses, passing a and b. Boom. Then we're going to come right here and we're going to say if g is greater than 1, then what we're going to do, if they are non-coprime, then we're going to remove both numbers. So we're going to say result dot remove last, put the parentheses. Oh, sorry. Then we're going to say that, call that again, and say result dot remove last and put the parentheses. Boom. Now we need to compute the least common multiple by coming right here, and we are going to come underneath this. Come underneath this, and we're going to say let LCM equal a divided by g times b. Boom. Then we're going to push the merge number back and check again in case the new top merges with the next one down. So just in case the new top now merges with the number 1 down. So we're going to come right here. We're going to say result dot append, open up the parentheses, pass in LCM. Boom. Then we can come right here. We just need to handle our else. So we're going to say else, open up the brackets. We could just break. Then we come all the way down here, and we just need to say return result. Boom. That should be all she wrote, y'all. Let's give it a run. Make sure it runs properly before we submit it. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 8 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the middle. Boom, then this is the helper function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.